Hi viewers, I am creating these videos to support teachers of maths in helping their learners make sense of mathematical concepts and their associated procedures and processes. And today I thought I'd look at converting a fraction into a decimal. Now, as maths teachers, we know there are a couple of different strategies that we suggest to pupils that they might employ with this, depending on the fraction that they are talking about. And so we're going to look at those strategies and how we might be supporting those strategies using manipulatives and using visuals. And I'm going to start with my Cuisenaire rods here, and I'm going to start with a relatively straightforward fraction like the fraction 7/10. Now, with something like this, if pupils have been introduced to the links between decimals and fractions already, then this actually becomes quite trivial. But if they haven't, then we can talk about this being our one whole. So this represents 1. And I'm choosing that, of course, because I want to represent the fraction family tenths. And this rod is 10 squares long, or 10 white rods long. And so this fraction would represent the fraction 7/10. And so at this point, the conversations we're going to have with pupils is, okay, well, each of these little white rods can be 1/10, and that is the same as the decimal 0.1. And we kind of have to introduce that first as a, 1 divided into 10 equal bits. So this is how 1 compares to 10, 1 dividing into 10 equal bits. And so this 7/10 would be 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. And so this would simply be the decimal 0.7. And like you say, pupils have already introduced fractions this way, and that link between tenth and the first decimal place, then this, it's relatively sort of trivial kind of thing. And then if I might want to move on from something like that, say, look at the fraction 2/5, well, then obviously a strategy we might employ here is say, right, well, let's look at the fraction 2/5. That yellow rod represents my one whole because I want to represent the fraction family fifths. So I'm going to use that to represent 1. So this is 2/5 because it's twice the size of 1/5, and each white rod at this point would become 1/5 if this is a representation of 1. And so what I might say is, well, if you simply put 2 of those together, 2 of those yellow rods, then we could now talk about the fraction family tenths. But if I did that, I'd need to be doing that as well. And again, if pupils have a good understanding of equivalent fractions in this using Cuisenaire rods or things like that, then this is nothing new, sort of doing that and saying, right, well, now, what if this was one whole? So what if this whole thing was one whole? So we should be recognizing this as an equivalent fraction to what we had to start with. And then, okay, what if this is one whole? Well, this is now 4/10. So in effect, what I'm saying here is that 2/5 is an equivalent fraction to 4/10, and therefore is the decimal 0.4. And I can go into slightly more complicated fractions, perhaps using my Dean's blocks rather than my Cuisenaire rods, and I could start to look at things like 47 hundredths as 47 over 100. There's 47 over 100. And again, if this is one whole, and provided pupils have seen this sort of introduction to decimal place value previously, defining this to have a value of 1, then this having a value of 0.1 and each of these having a value of 0.01 should be no problem. So I can see that this is 0.1, 0.2, 0.3, 0.4, and then 0.41, 42, 43, 44, 45, 46, 47, 0.47. And I could even sort of look at, say, something like 23/50ths, using that sort of representation and doing a very similar thing, saying, right, well, this is 50, here is 23 over 50. But if I create the equivalent fraction, but I'm just going to leave that very bit slightly separate for a minute, but if I create the equivalent fraction, then I can see that if I put these together, I still have something equivalent to 23/50ths, but now that is exactly the same as 100th. So what I have now is I have 46 hundredths, and the equivalent decimal will therefore be 0.46. And all of this is sort of all well and good. It relies on having been introduced to sort of fractions and decimals, and relationship between fractions and decimals in this concrete way prior to being able to convert between them. But once we're happy with that sort of decimal place value and how it arises from fractions in families of tenths or hundredths or thousandths, then we're sort of good to go with that. And it's a fairly sort of small leap to get to things like this, where of course we might have slightly more issues with something like this, 5/8. Now I can technically, particularly if I now make this 3D, I could technically represent that using the Dienes, and I could keep trying to scale this up, and we can see that I won't be able to scale it up into a 10, 100. I could eventually scale it up into 1,000, but being maths teachers, we know that I would need to repeat this 125 times and therefore repeat that 125 times to get it anywhere up near to 1,000. And so actually, in terms of that as a strategy, pupils recognizing that 8 times 125 makes 1,000 is potentially not a strategy that a lot of pupils are going to sort of tune into early doors. And very often what we'll do with pupils with fractions like that, or indeed fractions where the decimal becomes a recurring decimal, is to sort of treat it as a division. And for that, I could use my Dienes blocks. I'm actually going to use my place value counters for that, which will make it slightly easier. And I'm going to say, right, so I'm going to take this 5 and I want to create 8 equal shares. Well, of course, straight away, I can't share that 5 into 8 equal shares as it stands, because I don't have enough counters to fill each share. So what I'm going to do, of course, is I'm going to exchange that for 10 0.1s, and I'm going to start arranging these into 8 equal shares. So there's 8 equal shares, 1, 2, 3, 4, 5, 6, 7, 8, and I can start doing that with the next one, and then I can exchange these, and again, carry on creating my 8 equal shares, and I'm going to do that for all of these. And we can see, of course, that when I get halfway through, I get to half points of a share, which is obviously when I do that again, now I'm going to fill in that remaining half. So I'm going to exchange that and drag in there to create my 8 equal shares. And then I'm going to exchange that And now look, you see, I'm nearly there, and finally exchange that. Get my 8 equal shares there. But thinking about it, I'm going to make that 8 equal share at the front just to give myself enough space later on. There we are. And you can see I've got these two 0.1s left over that will not fit into my 8 equal shares. So, of course, what I'm going to do now is I'm going to exchange those, and I'm going to start carrying on creating my 8 equal shares from there. I'm just going to drag some of them out of the way for a minute. There we are. You can come out of the way for a minute. So I'm going to create my 8 equal shares here. And then I'm going to exchange this and create my 8 equal shares there. And now you can see I have these 4 left over, and I can't share those into my 8 equal shares. So now I'm going to start exchanging those and carry on creating my 8 equal shares. And of course, all this is it's the formal division algorithm just applied to that division. And then carry on exchanging. And I'm hoping I'll just have enough room to fit these in by the time I've finished doing all of my exchanges. And you can see so far I've exchanged 2 of my hundredths into thousands. So when I then go and exchange the final 2, I'm going to fill in this half. I think I'm not quite going to have room, at least not on that side, but never mind. And then the final exchange will allow me to fill these in, and then I'm just going to overlap them slightly so we can see they're still there. There we are. Obviously, it wouldn't be so limited for space if I was doing this using the physical concrete manipulative. And so now I can say, okay, what do I have in each share? Well, I have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. So I have 0.625. But if we look at what I actually did there, I said, right, I'm going to share this 5 into 8 equal shares. There were no whole ones in any of my shares because I didn't have enough ones. So then I exchanged those 5 for a total of 50 tenths because each of those 1 wholes was exchanged for 10 tenths. That allowed me to put 6 in each share. And normally I'd do this side by side with what I was doing here. So I'd say, right, with 6 in each share, we had 2 of the 0.1s left over. So we had 0.2 left over, and that became 20 hundredths when we exchanged it, which allowed me to put 2 hundredths in each of the 8 shares and left me with 4 of the hundredths left over, which became 40 thousandths. And then that meant I could put exactly 5 of my thousandths into each share. And so I ended up with 6 tenths, 2 hundredths, and 5 thousandths in each share. And normally I'd write that alongside this so we'd see what's happening at the same time, both in the sort of symbolic language as well as with the physical manipulative with the numbers as well. So that's my short video on sort of the links between fractions and decimals and converting fractions into decimals. As always, I'd like to say a big thank you to mathspot.com and its creator, Jonathan Hall, for the fantastic website that houses all of these virtual manipulatives that I am using to help create these videos. But not only the virtual manipulatives, you can see there are all sorts of other bits and pieces that are on that website, and it's well worth your time as a teacher of maths looking at what that website has to offer you to help your learners. And as always, if you are interested in looking at visuals and manipulatives and using them to support learners in making sense of what is happening when you go through these processes or procedures, or help make sense of these concepts, then you can check out my website. That's visiblemaths.co.uk. And there's a section in my website where you would see these images normally, but there's a section on my website called Visible Maths Book. And if you go to there, then this is about my book, Visible Maths. And on this section of the website, there is a link to the publisher. The publisher is Crown House Publishing. And if you scroll down, you'll be able to take a look inside and see some of the sample pages from that book. And if you feel like it would be useful to support your teaching and learning, then you can, of course, place an order. I'll be creating these videos throughout lockdown and potentially beyond. So if you have a particular process or procedure or concept that you feel like you would want modeled using manipulatives or visuals and see how that works, then please do get in touch, and hopefully I'll get around to creating it for you. Thank you very much for your kind attention today.